Class example 1.8.1. Simplify the following expressions. Write all answers as positive exponents. Now there's a few things to remember when we're using that verb simplify. There's multiple ways that we can go about simplifying things, but we do not want to have the same base. So you can see x and x, or m and m, or y and y. If we can prevent having more than one, then we'll combine them. We definitely do not want to have negative exponents, so we'll get rid of the negative exponents. But when we have something like an x and a y, we cannot combine them because they are not the same base. So we'll just have to watch ourselves here with some of the rules. Some of these are already simplified. I can see one right now, and let's go through the first one and see how it goes. X cubed multiplied by x to the power of negative 2. Now this is a Math 9 rule that we're now applying a 10c negative exponent to. We know that if we are multiplying two bases with the same base, we get to add the exponent. So I could rewrite this as x cubed plus negative 2 as the two exponents get added here. And I see that 3 plus negative 2, which is the same thing as saying 3 minus 2 is actually 1. So we can say that that's x to the power of 1, but we also know we just sometimes don't write x to the power of 1. Not wrong, go ahead and do it, but just a simple x would be sufficient as well. Another thing I just wanted to point out with this one, I'm just going to go off to the side here, x cubed multiplied by x to the power of negative 2. Don't forget that that negative sign is actually just changing our location. So we can actually rewrite that as x cubed, and now we know that the negative sign indicates that it gets switched into the denominator as it was on the numerator before. It does not change this to a negative. All it does is change the exponent from a negative to positive, and then we know we've changed its location. We also know that if we are multiplying two fractions, first of all, I can put anything over 1. I've got x cubed over 1 multiplied by 1 over x squared. That's the same thing as multiplying the top two fractions, or sorry, the numerators and the denominators. X cubed multiplied by 1 is x cubed, and 1 multiplied by x squared is just x squared. So we can see that this Math 10c rule with that negative exponent actually goes back to the stuff that we did last year in Math 9. And I can see now that if I've got the same base with two exponents here, I can actually subtract them. That's what I was saying earlier. 3 minus 2 is 1, and I get x here. So two different ways that we can do the same question. Okay, x squared y to the power of negative 3, all raised to the power of 4. We have a few ways that we can do this. We can first apply the negative by moving that into the denominator and making a nice positive exponent, which is what the question's asking us, or we could apply the 4 to both those two terms on the inside. I'm going to move the y onto the denominator first. Now notice that that negative 3 is only applying to directly what's in front of it, which is the y. The x squared actually stays where it is, and the y to the power of now positive 3 gets moved onto the denominator. And just like we had in that previous question, we see that we've got the x squared on the top and the y cubed on the denominator, like we had over here, and now I'm raising it all to the power of 4. Now this becomes a Math 9 question after we get rid of that negative exponent. I can go ahead and now apply the 4 to both sides. Now don't forget that a power raised to a further power means that we multiply. X squared raised to the power of 4 is the same thing as 2 times 4, which is x to the power of 8. Y cubed raised to the power of 4 is the same thing as 3 times 4, which is 12. And now I cannot combine these two any further because they are separate bases. So I get x to the power of 8, y to the power of 12 as our final answer. Y to the power of 4 multiplied by y squared is actually a Math 9 question. We've already seen that when we have the same base, we get to just add the exponents, and 4 plus 2 is equaling to 6. Now, why have we put that on here if it's a Math 9 question? As a reminder, we cannot do the same thing when we are adding. So this y to the power of 6 can occur when we have a multiplication sign in between the y's, but if there's an addition sign in between them, you cannot combine them. They have different exponents. The only way that you can ever combine things with exponents is if they had the exact same exponent. It's called collecting like terms. So this phrase, or this expression, I'm sorry, is already simplified. Whereas when you have a multiplication sign, we can go a little bit further. X squared to the power of 3, that's a power raised to a further power, just like we did over here. I can see that that's going to be the same thing as 2 multiplied by 3, and 2 multiplied by 3 is 6, so I get x to the power of 6. Our next question here again is a power raised to a further power. Now we have options. We have a z in the top and the bottom, so we could combine what's in the inside of the brackets and then apply that outside exponent, or we could apply the outside exponent first. It's up to you. I am going to keep my brackets and deal with just my z's. Now in Math 9, I know that if I'm dividing two exponents with the same base, I get to subtract those two. 7 minus 3 is 4. And now I'm going to raise a power to a further power like we've done a few times. 4 to raised z to the power of 4 raised to the power of 2 is the same thing as 4 times 2, which happens to be z to the power of 8. And this question is very similar to the one that we had above, the very first question. So we could rewrite this as m multiplied by 1 over, m squared multiplied by 1 over m to the power of positive 5. We know that's the same thing as saying m squared over m to the power of positive 5, as we saw earlier. And then I can go ahead and subtract those two. 2 minus 5 is negative 3. Here's our problem. It said we needed to write this with a positive exponent, but I know to write it with a positive exponent, I can just put it on the denominator. So my last question is 1 over m cubed.